Okay, so one more type of friction is rolling friction. See, till now you guys studied about static friction, kinetic friction, correct? So now what we are talking about is a rolling friction. See, rolling friction is, suppose let's say you have a cylinder or a sphere or something, okay? Then you roll on a surface. Now, once it's rolling, after some point of time it stops, correct? Now, why does it stop? It stops because of rolling friction. Okay. Now, whenever two bodies, suppose let's say one body is rolling over another body, and that friction is what we call as rolling friction. Okay. Now, see, imagine, let's say you have a smooth surface. Okay. You have a smooth surface, and let's say you have a sphere, a perfect sphere. Okay. So, in that is also very smooth. Alright. Now what happens, let's say the sphere started rolling. Now, since both the surfaces are smooth surfaces, ideally what should happen, that the sphere should never stop. It should keep on going. Okay, that's an ideal case. But actually speaking, that doesn't happen, right? Actually speaking, that won't happen. Now, what is the reason behind this rolling friction? We need to know. Okay, see, static friction and kinetic friction, what happens in these two? These two, one body is in contact with another body, it has some surface area, correct? Right, so like as you can see in the picture, so you have one body in contact with another body. Either you move it or is it stationary? It depends on what type of friction. Okay, anyway, that you guys learnt about it. Now, whenever we have rolling friction, see, rolling friction is almost about 100 to 1000 times smaller than static or kinetic friction. Okay, it's very less. Alright, now why is it less? What is the principle or what is the reason behind this rolling friction? Let's try to see. Okay, now look at the figure. See, what you have is, we are talking about intermolecular distance. Okay, intermolecular attraction also you can say. Now, actually, like in reality, what happens is, suppose let's say one body is rolling over another body. Now, because of these two things are in contact with each other, a little bit of wear and tear of the rolling object happens here. Okay, so because of uneven surfaces or because of any other reason, okay, there are a number of reasons why wear and tear can happen, because of heat, because of maybe something else also. Okay, now because of this, because of the wear and tear, what happens is the intermolecular distance and intermolecular attraction between the two objects, that starts changing. Okay, that will start changing. Now once that starts changing, what happens, as the body rolls over another body, there is a very small surface area which is in contact with the surface. See, for example, let's say you have a cylinder. Okay, let's say the cylinder starts rolling. Now, at any instant of time, only a very small area of the cylinder is in contact with the surface, correct? Unlike the sliding friction, or unless if it's a static or kinetic friction, right? Where a huge area is in contact. That's not the case in rolling friction. So since we have very small area which is in contact, what happens? The friction becomes very small. Okay. Now the reason behind this rolling friction, the reason behind this was, see, it's something like, so that we were talking about intermolecular attraction, correct? Right. So the same thing happens here also. The intermolecular attraction between the surface and the body, that is actually the reason behind this rolling friction. Even though that is very small, that's the reason the rolling friction is also very small compared to that of static and kinetic friction. Understood, right? So this is rolling friction. Now, see, to avoid friction, actually, friction is quite important also, and it's not good also. We have both of them. Okay. Now, how we reduce friction and what are the uses of friction, what are the disadvantages of friction, you're going to see in the next video. Understood, right?